Good morning students. We will continue the previous class. In previous class we were discussing about the image formation by convex lens. There we seen first image formation. There we kept we imagined object was at infinity. Their image was produced at principal focus, and even that image was real, inverted and highly diminished image. Now second one, that already I said, the position of object in front of that convex lens, it matters. Based on its position, image formation is going to take place. So now look on the second case. Here look on this diagram. Okay, here again I have taken one biconvex lens. Okay, I have mentioned this is this is optical center. Okay, and here f dash there and 2f dash there. What this? F dash is what principal focus point. Okay, OF and here one more OF. That's why I mentioned it as a 2f f dash. O to F, how much distance is there? Same distance you have to take between F dash and 2F dash. Okay, yes. F dash, 2F dash, okay, for this surface. Similarly, for this side, F and 2F. One thing we should know, O to F and O to F dash distances are same. F point and F dash point are at equidistant from the optical center. Okay? Yes. Now, see, concentrate. While drawing the diagram, it's very important. You have to represent like that. They are equal. You have to mention the points like that. O to F dash and O to F are looking like same. O to 2F dash, O to 2F looking like same. They are same. That's why you have to represent their distances looking like same. Then only you will be getting the correct ray diagram. That's very important. Okay? Yes. And even one thing, while drawing the ray diagram, you must and should represent the arrow mark. Long back I said, if you will not mention arrow, then we will not treat that as a light ray. Light has its propagation direction. So you must and should mention the arrow mark. If you will not mention arrow mark while drawing the ray diagrams, you will not get marks for that. Okay? Very important. Try to get it. So now here look on this one. Okay? Yes. Now here we are, in first case we placed the object, we imagined the object at infinity. Now you just imagine that object came from that infinite point. Somewhere it is there. Look here, look on this diagram. This is center, optical center. Infinite point somewhere there. That object right now, AB is object. See, right now here, AB we have taken as a linear object. Linear object means it has certain height. Okay? AB is a linear object held vertically upward with respect to principal axis in front of that biconvex lens. Okay? In front of this, we held that AB vertically upward. Now you see, where we placed that object? Now here we placed that object beyond 2F. Beyond 2F. Somewhere. Okay? Beyond 2F, somewhere you place that. Yes. Here I have placed that object AB. Fine. Now we have to draw the ray diagram. Firstly, what we have to do? Firstly, from the top of that linear object AB, you take one parallel line like this. you have to take one parallel light, a light ray 1. Okay, a light ray which is coming parallel after getting refraction from the convex lens which is passing through the principal axis. Through the principal focus. A parallel light after getting refraction is going to pass through the principal focus. Yes, here it passes. Getting what I mean to say? Yes. Take one more light from that top portion only. This light, this is 2. Yes. You take that light in such a way that it is passing through the optical center. You take second light ray in such a way that it is passing through the optical center. A light ray which is passing through the optical center will not get any deviation. It keeps moving straight. You see here, you have taken 2 light. To get image, at least 2 refracted light ray we need. Where they get intersect, there they will produce the image. At least we have to take 2 light rays. One, you have to take a parallel which is passing through the principal focus, and another a light which is passing through the optical center. Now this one, this light and this light, these two are refracted light. These two are refracted. These two refracted light rays got intersected here. Here at this point they produced the inverted image, image of this object. AB, it held vertically. See the top of that object AB is here. That top is produced here. In which kind of image you got? Inverted image. Getting what I mean to say? If you take 2 light rays from bottom, their image will be getting here. That's why I mentioned at that point as A dash. A dash is the image of A. B dash is the image of B. Totally A dash, B dash is the image of object AB. How it looking here? It looking held vertically downward. The top of the object is right now here. It held vertically downward. Are you getting? Very simple. 2 light ray you have to take. One from parallel. One looking like parallel, passing through the principal focus. Another passing through the optical center. Where they are going to intersect, there they are going to produce the image. Okay? Yes. In this case, you see here, you placed the object beyond 2f and you got the image between f dash and 2f dash. Getting what I mean to say? That side, if you keep the object beyond 2f, then image is going to present between f and 2f. Getting what I mean to say? Or else f dash and 2f dash. Which kind of image you got? That image is, those 2 refracted light ray actually got intersected, actually got met. Means what? The physical presence of image is there. So it is real, inverted, magnified or diminished. According to diagram even you can say the height of that produced image is lesser than the height of object. According to your ray diagram you can observe that height of that produced image is less than the height of object. So it is a diminished image. What is the nature of image? It is real, inverted, diminished image produced between f dash and 2f dash. Have you understood? Yes, this is a second case. What is the nature? If they ask, then at that time you have to say real, inverted, diminished image. Okay? Yes. Now you see here, third case. This is very important case. Okay? Now you see here. Yes. Firstly, object we imagined at infinity, and secondly we imagined object beyond 2f. Now in third one we imagining object is at 2f point only. Now you look on this diagram, object is at 2f. Okay, again now at 2f you have to place a linear object AB. Again you have to take two light rays. One is parallel, pass it through the principal focus point, and from top one more you take which is passing through optical center. Look here, first light ray, parallel one, passed through the principal focus. Another one from that top you have to take and allow it to pass through the optical center. These two refracted light ray got intersected here. I mean the image of this top produced here. Mean it got inverted. Okay, you draw here A dash B dash. You look here in this your diagram that A dash B dash is the image. A dash B dash is the image of object AB which is placed at 2f. Look according to diagram. Where you got that image? You got image also at 2f. Image also at 2f or 2f dash. Okay, and even you can observe the height of produced image with respect to object. What you find? You will find same size, same height image is produced. Are you getting? Same size image produced at 2f only. Very important. Object also placed at 2f, image got also at 2f, same size. Yes, what is the nature here? It is existing, physical presence there. Okay, so real held vertically downward means inverted, real inverted, same size image. According to diagram you can see real inverted same size image produced. It's very important. In exam they will be asking at which position in front of biconvex lens its linear magnification becomes 1. Linear magnification means what? Already I said it is a ratio of height of the image to the height of the object. H dash by h, where h dash is the height of image, h is the height of object. H dash by h. They will ask question like this. It's very important question. In front of biconvex lens, at which position? Okay, at which position their linear magnification becomes 1 or minus 1. Okay, if you go with the sign convention, it looks like minus 1. Getting where it becoming? At 2f position it will become. When you keep object at 2f, image is going to produce at 2f same size. Height of the produced image is same as that of object. That's why h dash by h. Same. That's why magnification will become 1. Why minus 1 they will take? The height which is vertically downward, that we have to take as minus. If this is 1 centimeter, this is also 1 centimeter. This is minus 1 centimeter, that is plus 1 centimeter. Minus 1 by plus 1, that is minus 1. Getting what I mean to say? They will ask like that. It's very important. Have you understood this? Yes. Now, see here. Now, fourth case. Now, object is going to place between f and 2f. Okay. Now, in this case, object AB is placed between f and 2f. You think like that. When object was at infinity, image produced at f. When object is beyond 2f, image is between f and 2f. Here, according to our number, object is coming towards the lens. Object is coming towards the lens, image is moving away from the lens. This is biconvex lens. In first case, object was at infinity, image was at principal focus. Here, this is principal focus. When object was taken from infinity to somewhere beyond 2f, image produced between f and 2f. It was in previous case at f. In the next case, it shifted between f and 2f. I mean, image is moving away from the lens. When object is approaching the lens, image is moving away from the lens. This imagination you have to keep in your mind. It's very important. As you are taking object near to the lens, near to the biconvex lens, image is moving away from the biconvex lens. Yes. Infinity at f, beyond 2f, between f and 2f. Now at 2f, this side also at 2f. It was moving. Now if object is between 2f and f, it shifted inward, then image is obviously going beyond 2f. Are you getting what I mean to say? As this object is approaching the lens, image is moving away from the lens. That we will to observe diagrammatically. Yes. Now come to the fourth case. Okay. Yes. Fourth case. Now here object AB is placed between f and 2f. Now again you take two light ray. One is parallel light ray from the top of the object and you pass that through the principal focus. Yes, this has passed this light ray. Okay, yes, it passed like this. Getting what I mean to say? Yes. One more light ray you have to take from that top portion only, which is passing through the optical center. Look here, these two are the refracted light rays. You extend them further. Somewhere here they got intersected. From where they came? From the top of the object they came. They passed through the lens and they met here. Means here they produced the image of that top. Then obviously that image got inverted. Here it is B dash. Getting what I mean to say? Now from this point you draw perpendicular to that principal axis. There you will be getting the bottom of that object. That is A dash. A dash, B dash. Now A dash, B dash is the real inverted magnified image. By getting this image, you can even observe the height of image is greater than the height of object. Have you understood? You see the dependence of position of object in front of that biconvex lens. Okay? Yes. Now, when object is placed between f and 2f, image got produced beyond 2f. 2f is here. I mean 2f dash is here. Both are same at equidistance. That's why I am saying O to 2f and O to 2f dash are same. That's why 2f I am saying. Okay. Now, an object between f and 2f, image produced beyond 2f. Which kind? Real, inverted and magnified image. Have you understood? Yes. Now, you see, already I said, as the object is approaching the lens, image was moving away from the lens. You can see from previous diagrams was here, shifted to 2f and shifted beyond 2f. Okay, I mean image was moving away. That side if you look, object was approaching the lens. Okay, this is about the fourth case. Now look here. Now here in fifth case we are placing that object at f point only. F point only. Now look on this fifth diagram. fifth diagram. Okay. Now object is at F point. Object is at F point. Object we placed at principal focus point. Now you see where image is going to produce. It's very important also. Very simple. Take two light. One is parallel and passing through the principal axis, passing through the principal focus. A parallel light ray passing through the principal focus. And from that top one, you take one more light ray which is passing through the optical center. Now you look on these two refracted light rays, how they are looking. These two refracted light rays are looking parallel with respect to each other. They are looking parallel with respect to each other. Then what we can conclude? They are parallel means somewhere at infinity they are going to meet. Getting what I meant to say? These two refracted light rays are looking parallel. That's why we imagining like that they are going to intersect somewhere at infinite point. I mean image is going to produce at infinity when object is placed at principal focus point. Getting what I mean to say? Then which kind of image that going to produce at infinity? These two, what we are treating, these two refracted light rays are going to meet at infinity. We saying mean we are saying real image is going to produce there. Real inverted highly magnified image is going to tell. We are saying why? According to previous analysis, when object was behind F, real inverted magnified image, as object is approaching, image is going to enlarge. That's why we saying here real inverted highly magnified image going to produce at infinity. This is the reverse case of first case. In first case we treated object was at infinity. Image got produced at principal focus. Now in this case, we keeping object at principal focus, image going to produce at infinity. Very important, they may ask in exam. You should be aware. If object at infinity, image will be at principal focus. If object itself is at principal focus, image will be at infinity. These 2 points you should know. We understood? Yes. So now here I have written about the nature of that object also. This is fifth case. Now final last one. In front of that biconvex lens we kept, we imagined firstly image was at infinity, beyond 2f, at 2f, in front of 2f, and at f we seen. Now in front of f, finally getting the last image formation. See now, sixth one. Now sixth one. Now we have to place that object in front of principal focus, or between optical center and principal focus, between optical center and principal focus. Okay, yes. So now here look on this one, what I mean to say. I place the object AB between optical center and principal focus. Again take two light rays. One is parallel, this one is parallel. Allow it to pass through the principal focus. Yes, it passes. Then one more, which is coming through the optical center. Yes. These two light rays, these two refracted light rays, how they are looking after refraction? These two light rays after refraction they looking like diverging. These two light rays were looking diverging. That's why diverging means somewhere they are not going to meet. We have to extend them in a backward direction. You see, I have extended this light ray backward in this direction like this. And even I have extended this light ray also backward in this way. See, these two backward extended light ray got intersected here. I mean, these two light rays looking like coming from somewhere here. Okay, getting what I mean to say? That's why they going to produce the image of this top point here. Here, yes, here that top point is there. Then from that you have to draw one perpendicular to that principal axis. This is right now the image. We feel like that the image of this object is there somewhere here. A dash B dash is the image of object AB. Which kind of image? These two light rays, when they reach your eye, you feel they came from this point. I mean, the image of this object, you feel it is here. You feel it is being there, but actually their physical appearance at that point will not be there. That's why we call this image as a virtual image. We feel like that it is there at that point. That's why it is a virtual image. Virtual, erect. Erect means what? Upright. How that image is there? Image is also vertical. We felt it held vertically upward. So vertically held upward means what? Erect. So what is the nature? Virtual, erect. I mean upright. Diminished or magnified? How we can see? Here we can see it got magnified. So nature is virtual, erect, magnified image. Okay? Yes, here we can observe that I have written. Say, I mean what? See, very important. Okay, about lens. We have seen image formation by the convex lens. One thing you have to imagine, in front of that convex lens, the position of object is very important. Okay, if that object is placed beyond the principal focus up to infinity, beyond principal focus up to infinity, that convex lens is going to produce real inverted image. If object comes in front of principal focus, in this case what we say, if object comes in front of principal focus, then convex lens is going to produce virtual erect image. Okay. Yes. Similarly, we now go with image formation by concave lens. One thing you have to imagine here, you have to remember, the position of object in front of concave lens doesn't matter, because in front of concave lens, wherever you keep that object AB, that concave lens always produce virtual erect diminished image. According to, in front of that concave lens, you keep objects at different position and draw the ray diagram by following the laws of refraction. Always you will get diminished, I mean virtual erect diminished images because of its diverging nature. Because of its diverging nature, that not going to produce a real image. You look here on this example. Here that biconcave lens is there. In front of that I have kept object AB somewhere here. Two light rays I have taken. One is parallel that came and it diverged. A parallel light ray is going to diverge in such a way that it is going to come from principal focus point. Have you understood? Yes. Then one more light ray which is passing through the optical center. Okay? Yes. These two light rays, how they are looking? They are looking like diverging light rays. They are looking like diverging. That's why you extend them backward. When you extend those light rays in backward, they will intersect here. See here, here there is image of that AB. Here they got intersected. They got Yes, see here. That object EB. From that object EB, we have taken two light rays. Okay, one a parallel. After getting refraction from concave lens, that going to diverge in such a way that if you extend it backward, it going to look like coming from principal focus. Then one more light ray which is passing through the optical center, it keeps moving without any deviation. I mean, these two are the refracted light rays. They looking like diverging. Okay, yes, diverging means they are not going to meet somewhere there. That's why we going to extend them back. We going to imagine they coming from somewhere. Okay, I mean you have to extend them in backward direction. Yes, here I have extended back. Now you see here they got intersected here. I mean there they produced the image of that object AB. Okay, the top portion of that object here it is produced here. I mean by that we can say that held again vertically upward. I mean which kind? It is vertically upward means erect. So now see here which kind of image we got here. Here we got virtual. Why virtual? We feel image is here. We feel only. As we go there we will not find any image. There is no physical presence. Only we feel it is there. That's why it is virtual, erect and diminished image. The size of image is small compared to the size of object, so it is diminished. Yes, irrespective of the position of the object, that concave lens always going to produce virtual, erect, diminished image only. That already I said. To come to know that, go with different positionally placed objects. I mean take that concave lens and place the object at different position and draw the diagram. You will notice always you will get virtual, erect, diminished image. That is because of its diverging nature. Yes, this is about the image formation by both convex lens and concave lens. Two things you have to remember. It's very important that convex lens is going to produce both real and virtual image. Convex lens is going to produce both real and virtual image. If object is beyond principal focus till infinity, that convex lens will produce real inverted image. If object comes in front of principal focus, then that convex lens will produce virtual, erect, magnified image. Okay? Yes. Then this is about convex lens. This concave lens is only going to produce virtual, erect, diminished images only. Keep in your mind, concave lens going to produce only virtual, erect, diminished images, that convex producing both real and virtual object.